Hello बच्चों, welcome to our YouTube channel and today's session is about irrational numbers. So आज हम बात करेंगे irrational numbers की. That is from your class 10 NCERT chapter number 1. So previous classes में आपने पढ़ाई है irrational numbers क्या होते हैं, उनकी properties क्या होती हैं, blah blah blah, right? लेकिन today we will actually use some theorems and we will prove that and we will learn how we can prove a number is a irrational number. तो सबसे पहले वो थ्योरम देख लेते हैं. This theorem says let p be a prime number if p divides a square then p divides a, where a is a positive integer. So if you want to write it down, we can say a square upon p, and result can be anything, right? So don't look at the result, but just focus on this part. So this part says if a square is divisible by p, then a is also divisible by p. But there is a given condition here. Condition says a is an integer and that's a positive integer, and p being a prime number. सिर्फ ये आपको याद रखना है, ठीक है? Now we will use this theorem to prove that _2, _3, the sum of rational and irrational number, etc. are irrationals. So let's just first take the example of _2. So _2, how we will prove that? First we will go by method of contradiction. So our approach would be, we will use method of contradiction. So method of contradiction क्या होता है कि हम किसी चीज को assume करके चलते हैं कि this thing is of a certain type, but eventually our theory will be proven wrong, and in that approach we are saying that whatever we have assumed was wrong, so the contrary would be true, right? लेकिन एक चीज इस मेथड को यूज करने से पहले हम डिस्कस कर लेते हैं. There are two types of numbers. One is rational number and another is irrational number, right? So if a number is not rational, then obviously it will be an irrational number and vice versa. So using this concept, now we're going to prove that _2 is an irrational number. So how do we say that? So let's assume _2 is rational, right? And if it is rational, then what we can say, _2 equals p upon q. And here the properties of a rational number are p is an integer, q is an integer, q is not equals to 0, and p and q, the co-prime is 1. That means their only common factor can be number 1. Cool. So let's go to the next step. We'll take a square, squaring both sides. So when we square both sides, it will work like this. So it will go p square upon q square. Next step would be 2 equals p square upon q square. And hence we can say 2q square equals p square, right? Or we can say q square equals p square upon 2. So what you can see here, you can clearly see, as per this equation, p square is divisible by 2. And what we know, p is an integer and 2 is a prime. So as per the theorem that we have just learned, it says a being an integer, p being a prime, if a square is divisible by p, then a is also divisible by p. So what we can say here, as per the theorem, if p square is divisible by 2, then p is also divisible by 2, and hence that means 2 is a factor of p. That's right. Okay, so now step number 2, now we can say p equals to r, right? R is another integer. And now if we replace value p, because what you can, if we, let's say squaring both sides first, p square equals to 4r square. And then if we replace value of p square from here, that will be 2q square. And that will become 4r square. So the next value, the equation would be q square equals to r square, right? And that means r square equals to q square upon 2. Again, if we apply the theorem, the same theorem will say q square is divisible by 2, then q is also divisible by 2. So that means 2 is a common factor of q, right? So what we have derived here, 2 is a common factor of p and 2 is a common factor of q. That means they do not have a common, they have a common factor other than 1 also. So our starting assumption was that underscore 2 was p upon q, and p and q both have common factor as 1. But now what we have derived, they also have a common factor as 2. So if they have a common factor as 2, they cannot be the rational number, right? So this is the method of contradiction. We started with an approach, we started with an assumption that underscore 2 is a rational number. And to be a rational number, the common factor has to be 1, but we has calculated that there is another common factor of p and q, that is 2. Hence, we can write down here, hence, as per the method of contradiction, underscore 2 is not a rational number. Rather, it's an irrational number, right? So this is the method of contradiction. So what you can do, you can go through all these steps. Sorry, I'm just teaching you, so this is not the proper way of writing an answer. You can beautifully write it down, cut down a few steps, because my intention is to make you understand the theorem, make you understand how you would use the method of contradiction and use that theorem to prove that underscore 2 is not a rational number, rather it's an irrational number, right? So that is what we have learned so far. So our next would be, let's apply the same thing on our next question, that says prove that underscore 3 is irrational number. So board gonna ask this question 100% every year. This question must come, and this question will come. So what would you do? You would just first write the theorem, and you would say if, or you can start with, say, given p is a prime number, if P divides A square, then P divides A also, and A is a positive integer, right? So when you start writing your answer, you have to write this theorem. If you do not write this theorem and say as per a theorem, we can say this, examiner not gonna give you the full marks, because you have to first write the theorem. And then what you would say, let's assume, your first step would be, let's assume underscore 3 is a rational number. Hence, we can write underscore 3 in the form of P upon Q. And most simplified, let's suppose P upon Q are the, P and Q are the integers. But if we divide them and derive to a number A upon B, where A and B co-primes is 1, right? Then the next step would be, we'll square both sides. So it will be underscore 3 square equals to A upon B square, or we can write it down as 3B square equals A square, right? Or we can say B square equals A square upon 3. And then we can use this theorem here, right? So if I go and just say this theorem, right? This theorem here that we have written there, we can say, if as per the theorem, this being, we all know 3 being a prime number, right? We don't need to prove it. We know that 3 being a prime number, A being an integer, and as per the theorem, 3 divides A square, then 3 also divides A. So if 3 divides A, means 3 is a factor of A, right? So we can say 3 is a factor of A. Now we only need to prove that 3 is a factor of A. We also need to prove that 3 is a factor of B. That means they will have a common factor of 3, and that will contradict our initial assumption here. So what we'll do next, if 3, and now we say if 3 is a factor of A, then we can write A equals 3C, squaring both sides. Or before you, okay, you can square both sides and say 9C square. And then you will simply replace A square with 3B square, right? Because now you have to prove that B also have a factor 3. So here you will say 3B square equals 9C square. 3 3 are 9. Then B square upon 3. I'm just going a little faster here. Then that means, as per the theorem again, this being a prime number, this being an integer, and as per the theorem, 3 will divide B square and also 3 will divide B. And if 3 divides B, that means 3 is a common factor of B. So what we have done here, we have proven that 3 is a common factor of A, and 3 is a common factor of B, and that contradicts our initial assumption. So we can say here, clearly we can say, because 3 is a common factor of A and B, so underscore 3 cannot be a rational number as per the method of contradiction. Right? So I hope you guys have understood what I wanted to teach you today, right? So we looked at the theorem. We looked at this theorem. Let's go to the top. This theorem says if a is an integer, positive integer, and p being a prime number, if p divides a square, then p also divides a. So that means we can use this theorem to prove some irrational numbers. And how we have proven that, we have taken the approach of, or we have used the method of contradiction. तो हम क्या कह रहे हैं यहाँ पर, हमने पहले एक थ्योरम का यूज किया. Theorem is very straightforward. You do not need to know how to prove that. If you want, type in the comments or leave your suggestions in the comment. In the next session, I can also show how easily you can prove this theorem. And using that theorem and the method of contradiction, हमने शुरुआत की ये कहकर कि _2 is a rational number. _2 एक rational number है. And you all know, because you have studied in class 9 also, to be a rational number, if a number is a rational number, then we can actually write it down in this form, p upon q. P is an integer, q is an integer, q is not equals to 0, and their co-prime would be 1, right? So these are the properties of a rational number. And then with a series of steps here, what we did, we squared both sides, and then finally what we proven for _2, that 2 was also a common factor of p and q. So if we said rational number can only have one common factor, but we have proven that this number will have a common factor of 2, that means _2 cannot be a rational number. And as per the concept of the numbers, if a number is not a rational number, then it will be a irrational number. All right. And similarly, we have taken that approach and we have proven that _3 is a irrational number. The same approach. There's no change in the approach. Nice and easy. And I can 100% guarantee this question will come up in your board exam next year. Right? So whichever year, CBSE will definitely ask this question. All right, I wanted to cover some other questions as well and some other discussions around the sum and differences of rational and irrational number and what is the result and how we can prove these sort of questions. And this will all be via applying the same concept, method of contradiction and using that theorem. ठीक है बच्चों, तो आज के लिए इतना ही. मिलते हैं नेक्स्ट लेसन में. होप आपको ये lessons pasand aa rahe honge, and if you like these sessions, like and comment on the video. That will motivate me to spend some time on it. Good luck and keep studying.